Hello Year 4 and welcome back to the start of a new week in maths. Today, in preparation for our work throughout the rest of the week, we're going to look closely at partitioning. But what is partitioning useful for? Where have we used it before? Pause the video, have a think about it. We actually use partitioning in lots of different areas of maths, particularly when we're calculating. And actually, when we use all four operations. For example, if we were going to add 58 and 27 in our heads, well, I would partition both those numbers and I would do 50 add 20, and then I'd do 8 add 7, and then I'd add them together. If we were subtracting, we might have 93 take away 46. Well, if I was doing that mentally, I would start with 93 and I'd maybe take away the 40 first, so I'd partition the 46. I'd take away the 40 first and then take away the 6. And you know about partitioning in multiplication because we were doing it last week in the grid method. 34 times 6, we partition the 34 into 30 and 4. And actually you'll learn this week as well that partitioning is really useful for division too. Let's look at an example. So you've seen these before at school. Can you remember what these diagrams are called? It's called a part-whole diagram. And the reason for that is because the circle at the top here shows us the whole amount that we have. And then these two circles here that are connected to it show parts. And when you add those two parts together, they make the whole amount. So it's called a part-whole diagram. We have 72 at the top of our part-whole diagram. This is the whole amount that we have. This is our total. So the numbers in these two circles will add together to make 72. What would be the most obvious way to do this, do you think? Indeed, just split it into tens and ones. So we have 70 and 2, because 70 add 2 makes 72. And partitioning things into tens and ones makes a lot of different calculations easier. This sort of triangular arrangement of numbers also helps us to remember our number facts. You might have heard them called sister sums or fact families. Let's have a look. So we know that 70 add 2 is 72. Our part-whole diagram shows us this. So what else do we know? There should be 3 other number sentences that we know just because we know that 70 add 2 is 72. Pause the video and see if you can write all 3 of them down. Right, let's see. So if we know 70 add 2, we also know that we can switch those numbers round and 2 add 70 is 72 as well. Because remember, when you're adding, it doesn't matter which order you put the numbers in. We also know then that if we started with our total, we could then take away the 70 and that would leave us just with the 2 left. And then we can then do that a different way as well, because if we start with the 72 and we take away the 2, we're left with the other number from our part-whole diagram, we're left with 70. So just because you know one fact, that actually means that you know 4 different things. But we don't just have to partition 72 into tens and ones. We can do it any way we like, as long as these 2 numbers add together to make 72. So I've put 50 in one of my circles. Can you work out what belongs in the other circle? Pause the video if you need to work it out. Let's see if you're right. 50 add 22 makes 72. And again, we know those 4 facts because we know that 72 take away 50 makes 22, 72 take away 22 makes 50, and 22 add 50 makes 72. So we can partition our number any way we like. Partition just means to split. We can split our number into any combination as long as they still add up to the total. I've tried to help to demonstrate this by making these numbers different colours, because in art, if you're mixing red with blue, what do you make? You get purple. So if you're adding this number and this number, you'll get your total. Let's have a look at another example. So we still have 72 as our total, but this time I've put 38 into one of our parts. I want you to see if you can work out what goes in the other circle. And I've used my fact families to work it out because I know I've got 72 and 38. So under here, I've done a sneaky column subtraction. I've done 72, take away 38. Pause the video to find the answer for me. Have you got it? It should be 34. So the other part of our part-whole diagram is 34. 38 and 34 make 72 together. But what if I put conditions on one of my parts? So I still want to make a total of 72, but this time I'm not giving you either number. But what I want you to do is to make sure that your red number here is a multiple of 10. So it must be a number in the 10 times table. Pause the video and see if you can find 3 different ways of doing this. So 3 sets of numbers, 3 red, 3 blue, that would make 72. But remember, the red one must be a multiple of 10. Okay, here are all the solutions. These are all the possible part-whole diagrams that you can have for 72 if the red number is a multiple of 10. Have a little look and see if yours are there. Well done. Okay, this time, again, I've taken away the red number and the blue number, and I want you to make sure that the blue number is a multiple of 11. We did the 11 times table recently, so make sure that the blue number is in the 11 times table. This time, instead of just finding 3 combinations, see if you can find all of them. Try and work systematically. So if I were you, I would start by making the blue number just 11, 1 times 11, and then see how many combinations there are. I found 6 different combinations. Have a check against my answers. We can, of course, make it a little bit trickier. We could give our part-whole diagram 3 arms instead of just 2. So we've still got 72 at the top, but this time we've got 3 numbers to add together to make that total. This time I've changed the colour system a little. So this time we have brown as our total, and the 3 colours that you use to make brown when you add them together are red, blue and yellow. So what do you think my blue number is? Pause the video, see if you can calculate it. Okay, so I know that when I add 40 and 22 together, it gives me a total of 62. So how many more do I have to add to make 72? Well, the blue number is 10. And we can double check this by using column addition if we want to add all 3 numbers together. So again, what if I put conditions on these circles? So what if I tell you that your total is 72, but this time your red number must be a multiple of 5, your blue number must be an odd number, and your yellow number can be anything you need it to be. Pause the video to calculate some possibilities. Now there are far too many possibilities for me to show you all of them this time, because in your multiple of 5, you could have any number that ends in a 5 or a 0 all the way up to 72. Your odd number could be any odd number as long as it's less than 72. So anything that ends in a 1, 3, 5, 7 or 9. And then your yellow number, of course, could be literally anything up to 72. As long as all 3 numbers add to make a total of 72. These are the ones that I did. Yours might look different, but as long as the red, blue and yellow numbers add to 72, then it's correct. Remember, you can use a calculator to check your answer if you want to. I used some written methods to work out my answers. I wonder if you did as well. So I decided on my red number and my blue number based on the conditions that I was given. And then I added them together using column addition. And then once I had that total, I could then take it away from my total to see what I had to put in the yellow box. So I did 72, take away 52, which was my total that I made with the red and blue, and that gave me 20. So I knew that 20 needed to go in the yellow circle. And the same on this side. I chose my red number and my blue number, I added them together, and then I took that away from my total to see what I had left that I needed to put in yellow, and that was 25. So column addition and subtraction are really useful today. But it doesn't always go well. Remember, even the best mathematicians make mistakes sometimes. Have a look at this one and see if you can find out why it won't work. So this person has chosen 55 as their multiple of 5, perfectly acceptable. And they've chosen 39 as their odd number. Again, perfectly acceptable. So what's wrong with it? Why won't it work? Pause the video to talk it through. Well, the reason it won't work is because if you add together the two numbers you've got so far, they make 94. And already that's more than the 72 that we need. So we can't write anything in yellow. And in fact, even if we put 0, that's still too many. So make sure that you use numbers that are small enough that when you add all 3 of them together, it makes this total at the top. Don't go over that total. Right, let's talk challenges. So challenge 1 today is just missing numbers. So we're using a part-whole diagram that just has the total and 2 arms. And I've given you 2 of the numbers out of 3. I might have given you the total and 1 of the arms, or I might have given you both arms. You need to work out what the missing number is using column addition or subtraction. Challenge 2 involves conditions. So like we looked at just now when I said that one circle had to be a multiple of something, or it had to be an even or odd number. And you might be dealing with part-whole models with 2 arms and a total, or you might be dealing with part-whole models that have the total and 3 arms. For each of the problems in challenge 2, I'd like you to find 4 different possibilities. So there are different potential answers for each one. Now we don't really have a super challenge today. Instead, we have an extra challenge. So it's not that it's particularly difficult, it's just interesting. The information for it is on Google Classroom, and it's basically a useful trick that you can use to identify whether any number is in the 3 or the 6 times table. And when I say any number, I mean you could look at a number in the billions and work out if it's a multiple of 3 or 6. Try it out with any numbers you like. Good luck today, work hard, and I will see you again tomorrow. Bye.